synchronization in art also. Can we study how we actually initiate the task, how we actually start the task in art also. Also, we are going to study how what are the different states of a task and how do we really control those states. Okay, so let's get started. I'll share my screen. Okay, so this is just basic overview. Basically, we have already covered this yesterday and before that. Okay, in the previous lectures, in the introduction, everywhere we covered it already. So RTOS is basically what is RTOS? It's an operating system. Okay, it is okay. Then what is so different about it? Why it is different? Okay, it is designed to handle different hardwares. Okay, hardware resources. And that's why it's different, and it is known for its time management. Okay, time management, accuracy, okay, and predictability. Okay, so so something that is very accurate with respect to time. You studied the hard and soft real time, right? So it's similar. Okay, whenever there is a time bounded operation. Okay, time bounded operation or dependency on time. Okay, this particular OS is preferred. Okay, and it's specifically designed for managing the hardware resources. Okay, then these main characteristics you already know. Okay, that has deterministic behavior, low latency, concurrency, priority based scheduling, interrupt handling, and real time performance. So what is deterministic? Low latency is fine, concurrency. Yeah. So concurrency you either. So concurrent because it manages the task based on the priority. Okay, and it has its own scheduler. Okay, so if I talk about scheduler, okay, it is a part of our kernel. Okay, and what happens is that this scheduler works on scheduling algorithms. Okay, and these scheduling algorithms decide which task to run when. Okay, also when initiating a task. Okay, if we are creating a task, okay, create task, suppose we pass certain parameters. Okay, that we'll study today, and depending on that also the scheduling happens. Okay, in the task run. So this is how it is maintained basically, and priority based. So here itself, while creating a task, we can set the priority or severity of the task from 0, 1, 2, 3, 4. Okay, 0 means highest priority, 4 or 3 means the lowest priority. Okay, then interrupt handling. It is fantastic interrupt handling feature because it is designed for that, right? So this is an operating system which is designed to handle dynamic things. If we focus, okay, most of things are happening dynamically in a hardware environment, and this operating system, you know, give justice to that sort of environment. That's why this is preferred. Okay, real time performance, of course. types we also explained yesterday. This is just a general difference between our regular OS and RTOS. Okay, so task scheduling and general purposes, time sharing, not deterministic. Okay, but here it is deterministic. We already know which task is supposed to be executed when. Okay, because we decide that. Okay, it's priority based mostly. Okay, latency in general purpose OS is high and here it is low. And why is that so? Your general purpose is OS is normally designed for multitasking and like performing very general tasks, but these systems are focused on a single task. Okay, focus on one, I mean, one feature divided among different tasks, I would say. Yeah, so let me share my screen again. Okay, so yeah, we were at the latency part, and we were talking about why general purpose OS have you know high latency when compared with RTOS. Okay, because these are focused on multitasking and performing tasks on really which are really general in purpose. Okay, so but RTOS is used where embedded systems are there, which are focused on one feature. Okay, one feature which is divided into different tasks. Okay, and we are gonna study today like how these tasks are managed. Okay, in coding. Okay, and life cycle of this task. Maybe or what else do we have today? We have basically states. Okay, yesterday I gave you overview of the states, but today we actually gonna study the states. So I'm saying latency is high in general purpose OS, and here is it is low. But when performing day-to-day activities, we may not notice that latency. But the latency I'm talking about is in form of milliseconds. But those milliseconds also matter. Okay. So interhandling. These are like RTOS is generally priority based scheduling happens in RTOS, right? And that's why we get immediate response, but lower priority and slower general purpose OS are. I mean, I'm not saying these OS are bad or these OS are not should not be used anywhere, but it is on your use case, okay? Where you want to use what, okay? It's on that and it's not on which is better. Okay, so it is, as I told you, this is for focused application and this is for general purpose application. So of course there has to be difference in between these two. Okay, and of course RTOS are simple, efficient for real-time tasks, and these are complex because again this is very general OS and it has a lot of things to do, and these things are managed in the single package. So definitely it is going to be complicated. In use case, definitely embedded systems and desktops or servers. Scheduling algorithms we have. Okay, anyways. So let's start with task management in RTOS. So if you noticed, that window had this word called free RTOS. What is free RTOS then? Okay. Just a second. Okay. So so Atos also has a lot of flavors. Okay. So there's so many of them. Okay. So to go into specific Atos, I'll be talking more about free Atos. Okay. And this is one of the flavor of Atos, and we'll talk about this in today's session. Okay. So everything is similar. Okay. Just that they are different flavors of the same operating system, and these we can mold according to our use case. So we whatever we are going to talk today is in general RTOS, okay, but few terms, like if I'm mentioning specific functions, if I'm mentioning methods to initiate the task, if I'm mentioning methods to terminate or abandon the task, then that is relating to free RTOS. Okay, the names of function and the libraries are of free RTOS. So, so what can you see on my screen right now? PPT, whiteboard, browser, what is visible?
At the whiteboard.
Whiteboard.
Whiteboard, sir.
Okay, okay,
Whiteboard, sir.
okay. So now there here are two scenarios. Okay, time. Okay, so this is we are checking things against time. So what happens is that so there are three tasks in your current code. Okay, task one, task two, and task three. Okay, so when it comes to RTOS, what you will find is all three tasks are, I mean, if you look at uh, it from our application view, all three tasks are running at the same time. Okay, you will see your system running so smoothly that you will not even notice what is happening. What actually happens is that at particular point in time, only one task runs. Okay, only one task runs, and rest of the tasks are waiting in ready state to be run, okay, or in pause state. So suppose I'm dividing time axis. So this task one, this task two, this task three, again task one, again task two, again task. This is how actually it works. Okay, it it actually works like this, not like this. Okay, you might see your system running like this, but it doesn't work like this. Okay, this is how it works. At particular time frame, at particular interval in time, only one task runs. Okay, if multiple tasks are to be run at the same time, then we need to have multi-core wala processor. Okay, So that is not the case here. We want, when embedded systems are concerned, our hardware is already limited, okay? And in that, we have to manage all the tasks, and we have to have every task running, and we have to give impression to the user that our system is running seamlessly. How do we do that? This is how we achieve it, okay? Then it executes so quickly that we get an impression that it's seamless, okay? So so who runs these tasks? Okay, who runs these tasks? It is scheduler, okay? What is scheduler? It is, it's a part of kernel of the OS, okay? It is an OS, right? So it is having a kernel, and the scheduler is part of that. Okay, what the scheduler does is it looks at the priority, okay? Priority of the tasks, and depending on that, it runs it. So if scheduler detects that there is a lower priority task which needs to be executed before, then it will do that, okay? It has that sort of, we can say it has brain. Scheduler has brain. It can decide, but depending on what, okay? What is that deciding factor? Deciding factor is scheduling algorithms, okay? Oh shit. Fine. Not working for me. So it depends on scheduling algorithms, okay? Now, if we consider different flavors of RTOS, there are different scheduling algorithms, okay? So we'll study them. Basically, preemptive and non-preemptive, you already know. Yesterday we've seen this. So preemptive is like higher priority task and interrupt a running low priority task, okay? So higher priority task can interrupt, okay? Interrupt the task which is already in running state, okay? And the task is having lower priority, okay? But if it's preemptive algorithm, it states that if if a task is having higher priority, then it can interrupt any lower priority one task. Non-primitive is exactly opposite to this, okay? Exactly opposite. Then there is third type, which is fixed priority, okay? Something called fixed priority, in which, as the word express, the priority is fixed. It is not going to change, okay? The tasks are scheduled based on the static priorities. Like when we initiating the task, like when we are creating the task, suppose this is how I'm creating a task name and blah blah blah, and then I have some place where I decide the priority, okay? This is called static priority declaration. Static priority. So the fixed priority means we are giving static priority, okay? And depending on this priority only, the task is running. So if it is having zero given as a priority, means it has the highest weightage, okay? Highest priority. Whereas as the number will go on increasing, the priority goes on decreasing. on the lower side. Okay, this is how it works. And then dynamic priority scheduling. The static and definitely dynamic has to be there. Dynamic priority. What is dynamic priority scheduling? Okay, the task priority changes dynamically based on the various factors. Okay, like deadlines. Suppose I'm not mentioning the, suppose I'm creating a task here. Okay, here is the task name, task one. Then there are certain other parameters, and then there was priority, but it's not there anymore. We have not mentioned priority. Okay, then then there is fixed priority scheduling when we decide the priority. It is static priority. And how dynamic priority works is it works on deadlines. Okay, we give deadlines for the tasks. Okay, with respect to time. Okay, and respect to other tasks. So if deadline the deadline is closer, then the task gets prioritized. Okay, if closer the deadline, higher the priority. Okay, closer the deadline, higher the priority. Okay, and vice versa. Like if the deadline is very far, okay, then priority will be of course lower. So this is डायनामिक प्रायोरिटी. ओके, स्टैटिक में हम प्रायोरिटी इधर ही डिसाइड कर रहे थे, डायनामिक में हम डेडलाइन देंगे. ओके, depending on deadline. Okay, and when coding you can check. Okay, if like if certain parameter has reached certain value, then suspend maybe task one and start executing maybe task three. You can check in the code like this, like you would do in C, and complete your operation. Okay, so this is how it works. Sometimes based on priority, sometimes based on deadlines and all these parameters. Okay, बहुत थोड़े थोड़े changes है, लेकिन वो matter करते हैं. Okay, and these are nothing but scheduling algorithms. Okay, so basically in Atos, like you decide your strategy. Okay, you decide your way, your you decide the way your application wants to run. Okay, uh, similar way, just say uh, if you see in our day to day, you know, software deployment cycle. So there are some deployment strategies, right? Like for an example, canary. Okay, there are some other which are defined. Okay, already a defined standard, but there might be some applications where you are designing your deployment policies. Okay, you are deciding your deployment plan. Okay, so that is also acceptable. Okay, so similar way in artos also you decide how you want your tasks to run, and it is not dependent upon the fixed scheduling algorithm. Of course there are scheduling algorithms. Okay, but you get to control that. Okay, you get to control, you get to plan, you have to sit and you have to plan how your tasks should run. Okay, and depending on that you have to code, depending on that you have to put it on your code. So this is how it works. Then after that there is EDF. Okay, it is called earliest deadline first. Okay, we talked about dynamic, right? It is a part of that only. Okay, because dynamic mein, one part was to decide how the task run based on the deadline. Okay, but now they are saying there are sub parts also. Earliest deadline first is another algorithm. See, they have subdivided it now, and it is self-explanatory. I'm not going to explain. Whatever task is having deadline which is closer, that gets executed early. Okay, and then last uh, there's last one category which is called rate monotonic scheduling. Okay, RMS, which states that task with shorter periods given the highest priority. Okay, shortest periods means that suppose this time, okay, and tasks are running, okay, and, and this is time, okay. So some tasks are executed in 2 milliseconds, some are executed in 50 milliseconds, some might take 80 milliseconds, okay. This period, and this period matters, okay. If task 1 is running here, task 2, task 3, okay. And if we are talking about rate monotonic scheduling, how it works is that lowest period वाला जो task है वो पहले run होगा no matter what. Okay, lowest period वाला task पहले run. It could have the low priority, okay. But if we are saying my application, my feature, my code should run on the this thing, RMS, rate monotonic scheduling, then lowest period wala task gets the priority, period wala task runs. Okay, so um, what are the states of the task? We discussed it yesterday, okay, but now we are talking about free ATOs, right? Free ATOs, free are so state. So at any given point in time, our task can be in only two states. Okay, then the states can be further divided, but either it could be running or not running, right? If there is a task, it could be either running or not running, right? So let's see how it works. Not running, and let's say running. When the task is not, I mean, when the task is not running, it is basically in not running state. But these not running states are again further divided into suspended, ready, and blocked state. Okay, so suspended, then ready, and blocked. Okay, suspended, ready, and blocked. So any task which is in ready state, only that can go to running state. Okay, tasks which are in suspender or block state cannot go into running state directly. Okay, we have to work on that part. Like we have to, if we provide a partition here in between not running and running tasks. Okay, so if there comes a need, okay, like I told you earlier, if there comes a need wherein we are calling an function to check certain parameters, and we want a running task to go into any of the state, then there are ready-made functions available to do that. Okay, so suppose I want to suspend a running task, then there is something called v task suspend. Okay, v task suspend. If I if I call this, then my running task can go into suspended state. Okay, if I call this. Similarly, there is an API for blocking a running task. Okay, and if I call that blocking API wala function, then a running task can go into blocked state directly. Okay, so now what is difference between all these states basically? Let's first see that and then see all the functions and all. Okay. So basically, a suspended state is, it is the one of the state where the task is not running that we know. But why? Like we can suspend the task. Okay, we can suspend the task by using the function we task suspend. Okay, and to use the same task again, we need to resume task by using the resume wala function. Okay. So suspend कर रहे हैं हम task को. First thing is because of some reasons. Okay, because there could be something like only these many number of tasks can be run instead, only these many number of tasks can actually run, and only these many number of tasks can be in, I mean, particular states. That could be one of the reason, or it could be just task management in our task. Okay, we could be just managing the tasks different way. We could be just figuring out how to manage the task. So suppose um, just a second, I guess. Hey, you guys are following this, right? You are understanding, right? समझ में आ रहा है तुम लोगों को ये जो भी हो रहा है इधर?
Yes, sir.
Okay, okay. So we're talking about task. So uh, tell me then. Okay, okay. Wait, let me tell you. So हम task बोल रहे हैं बार बार. What is task then? What exactly is task? So task is nothing but our code only. Okay, part of our code. Suppose my code is let's say my code is, हमने जो भी कोड देखे आज तक उसी का एग्जांपल ले लेते हैं. My code is to write a keypad interfacing wala code. Okay, my application is keypad interfacing and displaying the value on the LCD. Then what is task exactly in this? Task would be first of all to detect the key press. Okay, that is the task, and I could set highest priority to that task. Okay, then initializing the LCD module, I could give maybe the lowest priority or mid priority to that, and then displaying whatever is pressed. And another task could be action on the key press. What you want to do on that key press. Okay, that could be another thing. So I can give that thing as maximum priority, action on key press. Okay, and if and display I could give lowest priority. So this is basically task. My point to explain you is that what exactly is task. हम एक कोड लिख रहे हैं, उसमें जो जो चीजें हम कर रहे हैं, that is nothing but task. Okay, let's continue. So, sorry. So we were talking about suspended state. Okay. अभी इसमें बेसिक चीज है, ओनली जो टास्क रेडी स्टेट में है वो ही रनिंग स्टेट में जाएगा. एंड रनिंग स्टेट वाला टास्क किसी भी स्टेट में जा सकता है. इट कुड बी इधर ब्लॉक और सस्पेंडेड. ओके, or it could again go back to ready state. Okay, because some certain tasks, we run frequently. Okay, similarly, a ready task can be converted into suspended state and vice versa. Okay, so what do we really call v task? Again, v task suspend we call it. If we call v task suspend, then it will go back to suspended state. And if we call v task resume, v task resume, then it can again go to ready state. And a ready task actually wait in queue to be executed, and depending on priority they are picked. Depending on okay. Now depending on not only priority, depending on the scheduling algorithm, okay, that we are using, the tasks are picked. What is the parameter that we have set for the task to run? Okay, that actually matters. So depending on that, the task can go to running state at any point in time. Okay, but it depends on what? Lot of parameters. Okay, so this is how it works. The ready task can go to running state. Okay, and the ready task all are waiting to be run. Okay, all are waiting in a queue to be run. Okay, it could be waiting on resources, or it could be waiting for their turn to come, or it could be waiting maybe on the priority. It could be having, deadline which is not too close, farther far वाली deadline हो सकती है, इस वजह से भी wait कर सकता है task. So there are a lot of things here. Okay, and suppose in this case अभी deadline फार है, ये केस के बारे में बात करूंगा. तो deadline अगर बहुत पास नहीं है, so we usually don't keep the task in waiting queue. Okay, we suspend such tasks. Okay, and when the actual time comes, we call v task resume for the particular task, and again the task comes back to ready state, and then it runs when it actually has to run. Okay, so now block task. If suppose I have blocked the task by blocking, calling the block wala api, then how does it go back to ready state? Okay, now it has to be event triggered only. Okay, it has to be event triggered. Okay, a block task can go to ready state. A block task can go to ready state, but it is event triggered. Okay, we are not calling any function to resume it. We are not calling any function. It is event trigger. It could be an interrupt. Okay, that only can trigger the block task and cause it to go into ready state and then further to running state. Okay, so अभी तक समझ में आ गया. A task can either be in the not running state or running state. These are states of the task. Okay, and then not running state is further divided into suspended, ready, and block state. Okay, then the running task can go into either suspended or block state. Only these two states. Okay, a running task we can suspend by calling v task suspend, and a running task we can block by calling an API. Okay. Then talking about ready state, a ready task can be suspended by calling meta suspend, and by calling meta resume, suspended task can go back to ready state. Okay. At the same time, a block task can go to ready state when an event is triggered, an event is called, an event occurs. Okay. It is only event based. Now there is one more thing remaining here. A block task can also go to suspended state. Okay, a task is blocked. We can take it to suspended state and then ready state. Okay, बहुत ज़्यादा कचरा हुआ है इधर में. So here is my ready state. Here is my blocked state, and here is suspended state. Okay, and here is running actually. So I told you, there is only one way for block task to go back to ready state. Okay, by an event trigger. Okay, but this is the only direct way we can do that. Okay, there is a loophole. What we can do is a block task can go to suspended state. Okay, ब्लॉक टास्क को हम सस्पेंड कर सकते हैं। ओके, वी टास्क सस्पेंड। ओके, ये कॉल करने के बाद ब्लॉक टास्क सस्पेंड सेट में जाएगा एंड वी टास्क रिज्यूम कॉल करेंगे तो ये अगेन रेडी स्टेट में आ जाएगा एंड देन रनिंग में आ जाएगा। ओके, आगे समझ में। रनिंग टास्क कैन इधर गो टू रेडी स्टेट और रेडी block state. Okay, here we have to call API. Here we have vtask suspend. Then सस्पेंशन से रेडी स्टेट में टास्क जा सकता है एंड वाइस वर्सा। ओके, रेडी से सस्पेंडेड में भी जा सकता है बीटा सस्पेंड। बीटा से रिज्यूम से वो रिज्यूम कॉल करने से नीचे आएगा वापस रेडी स्टेट में। ओके, ब्लॉक का ये है। ठीक है, ऑल द पाथ्स आर लाइक दिस हियर। या दिस इज द फाइनल रिप्रेजेंटेशन ऑफ स्टेट्स। कल हमने एक रफ डिस्कशन किया था। सो दिस इज हाउ द स्टेट्स ऑफ द टास्क changes. Okay, understood? Clear to you guys? Clear so far?
Yes, sir.
Okay, so let's go for a break, 5 minutes break. Okay, and come back. Hi guys, are you back?
Yes, sir.
Okay, so let's resume. What we were talking about is states, okay, and the tasks. So also we talked about what exactly is task. So uh, just to brief you, the task is nothing but our code which is divided into different parts, okay, and those parts are known as task. And we learned how each part of it, how each task goes from a state to other, okay, from running to suspended, from suspended to block, from block to suspended, from block to running. How does it happen? Okay, we saw that. Then we also saw that how a task goes from running state to any other state, or from any other state to you know running state. I mean, a task can either be in running state or non-running state, and non-running further divided into block, suspended, and what was the third one? Ready state, definitely. So, ready state is the mediator of all. Task has to be in ready state in order to run. Okay, these are few things that you should remember. Okay, and okay, so we'll move on now with we talked about the states. Now we'll see how to create a task in FreeRTOS. Okay, share my screen. What can you see on my screen right now?
Whiteboard.
Okay, thank you.
Whiteboard.
So, so, as I told you, task is nothing but a program. Okay, program which is divided into smaller part, which is called task. Okay, and every task is performing its own specific function, right? So, if we take an example, suppose we are reading a temperature, okay, from temperature sensor, okay, and what we are doing is we are reading the temperature and displaying it on the LCD, and then our task can be divided as if I'll tell you how. So if we are reading the temperature from a temperature sensor, okay, and then we are displaying it. Okay, so let's first understand what all are the things involved in this particular case. So I have some sort of controller, okay, any controller it could be. We don't care now which controller it is, okay. I have a temperature sensor is interface to microcontroller, and microcontroller is displaying the data on LCD. Okay, so टेम्परेचर सेंसर से डेटा कौन सा आता है एनालॉग डेटा आता है बट आवर कंट्रोलर ओनली अंडरस्टैंड्स डिजिटल डेटा राइट इसको समझ में नहीं आता है जो भी सेंसर का आउटपुट रहेगा our controller won't be able to understand that. So there is need of ADC, analog to digital converter, in between these two. Okay. So many microcontroller have, you know, inbuilt inbuilt ADC module. Okay. इनबिल्ट एडीसी होता है हर, मतलब अब आजकल के माइक्रो कंट्रोलर्स में तो है ही. ओके. फ्रॉम पिक इट स्टार्टेड. पिक माइक्रो कंट्रोलर से ये स्टार्ट हुआ. ठीक है. इनबिल्ट एडीसी होता है. सो इसमें टास्क कौन से है हमें वो देखेंगे. ठीक है. तो या सो we have we have a sensor, we have ADC conversion, and we have display. So first task would be to read the ADC value at any ADC pin of the microcontroller, okay, where temperature sensor is connected. Okay. So first task हमारा कोड में क्या रहेगा? Read the ADC की value. Okay. ADC value. Okay. At any pin जो भी connected है, any ADC pin. Then second would be to convert the ADC value into equivalent temperature value, right? Because ADC ka value is also not a proper value. We have to convert it into a valid temperature. So that will be second task. Convert the ADC value into equivalent temperature value. Okay. And third task would be to display the temperature value to on the LCD. Okay. Display the temp on LCD. Okay. LCD module. So ये तीन क्या बन गए? टास्क बन गए. ठीक है. So are you getting now how tasks are defined? Okay. पहले मेरे पास सिस्टम डिजाइन आया. ठीक है. It could be any system. So then I sat with my team and I decided कि ये सिस्टम डिजाइन करने के लिए मुझे कौन से टास्क लगेंगे, हाउ मेनी टास्क शुड बी देयर. ओके. एंड हाउ डू वी राइट देम. सो मैंने ये रफ इसका आइडिया मेरे पास आ गया कि मेरे पास 1 2 3 ये तीन टास्क है. फर्स्ट टास्क इज टू रीड द एडीसी वैल्यू. ओके. एट एनी एडीसी पिन दैट इज देयर. ओके. देन कन्वर्ट द एडीसी वैल्यू इनटू इक्विवेलेंट टेम्परेचर, बिकॉज एडीसी की वैल्यू भी रैंडम रैंडम स्टफ ही रहेगी. ठीक है. इसको हमें इक्विवेलेंट टेम्परेचर में कन्वर्ट करना है. सो दैट इज अनदर टास्क. And then third task is displaying the temperature on the LCD module. Okay. So displaying the temperature on the LCD module. So that task means now this display wala task is again huge task, right? LCD का init होता है, then command routine होता है, then data routine होता है. So ये सब, लेकिन ये सब एक ही टास्क में लिखना है. ठीक है. So this is how I decided my task should be. Okay. So after creating the task, we can, what we can do is we can set the priority according to the critical nature of the task. Okay. Here, okay, ये इस case में क्या होगा? To read the ADC value has the highest priority and display the value has the lowest priority. Okay. So I can do that. I can say reading the value has highest priority, whereas displaying the displaying on the module has lowest priority. Okay. And why is that so? Because reading is important. That might take time, reading and conversion and having a proper value in place. So that might take another few milliseconds or microseconds, whatever it could be, depending on the speed and the selection criteria. So it could be anything. So what I have decided is reading gets the highest priority, displaying gets the lowest priority. Okay, so this is how it can be actually done. Now let's see how an actual task is created here. So suppose, uh, let me remove all this. So task creation. Now we need to know, like in RTOS, we create task by using a command. Okay, it is x create task. Okay, x create task से हम create करेंगे. Okay, it takes 5 arguments. Okay, which defines various feature of the task. Okay, so first is like x create, x task create. Okay, ये सब commands again I am telling you ये free RTOS के लिए. ठीक है, free RTOS is a flavor. Okay, x task create. Okay, x task create, and then there are 5 arguments. Okay, 5 arguments which are passed, and depending on that, features of our task are designed. Okay, so first is my task pointer, next is task ka name, third is stack depth, then parameter, priority as I told you, and then task handle. So this is the syntax to create the task. Okay, so x task create, then we give the task pointer, then task name, stack depth, and parameter, priority, and then task handle. Now let's see what each of these arguments are and what do we define really. Okay, so first is my task pointer. Okay, my task pointer. What is this? There is nothing but it is a pointer to task entry function. Okay, we need to define the task with certain function, right? So it's just the name of the function which is used while creating a task. So it is, suppose अपने 3 टास्क डिसाइड हुए थे, राइट? पहले रीड करना है, देन वी हैव टू कन्वर्ट इट एंड देन डिस्प्ले इट. सो रीडिंग, सो टास्क 1 का मेरा नाम है टास्क 1 से रीड, टास्क 1 रीड. ओके, आर ई ए डी रीड. सो आई विल राइट हियर टास्क 1 रीड. आई मीन जो भी नेम होगा, फंक्शन का नेम होगा हमारे टास्क का, वो ही इधर आएगा टास्क पॉइंटर में. ठीक है, then task name. Now here you can write description. Okay, task name. Okay, you can put description of the task here, or the same thing that you pasted. So the pointer is basically the entry of the function की entry है वो. ठीक है, we'll do define the task with certain function, right? So it's just the name of the function which is used while creating a task. Okay, now next is task name. Task name is a descriptive name of the task. Okay, this is mainly used to facilitate the debugging. So descriptive name. So तुमने पॉइंटर में तुम्हारा जो फंक्शन का नेम है वो लिख दिया. सपोज फंक्शन क्लास में अभी यहाँ पे यू कैन से रीडिंग में भी रीडिंग टाइम मतलब डिबगिंग के हिसाब से ये इजी होता है, इसलिए इधर नेम में हमें वी हैव टू राइट सम डिस्क्रिप्शन अबाउट द टास्क, ओके, वी आर क्रिएटिंग. Then stack depth. What is stack depth? It is the size of the task stack. Task का जो stack होगा, okay, as the number of variables the task can hold. Okay, we have to define कि कितने variables अपना task hold करना hold करेगा. Okay, you get the control. You have to decide. Uh, I mean, you get to decide like how many variables does your task hold. Okay, this is but the stack depth. Okay, so uh, it's not the number of bytes. Okay, it's just the number of variables it can hold. Okay, we should make sure to select the stack size according to the complexity of computation. Okay, suppose if there is a code which is having lot of complex things to be done, then according to that we have to select the stack depth, because if you define the stack depth to be very less, then your function might fail. You might not be able to calculate, you might not be able to do certain things, and that could be because of the stack depth. अगर तुमने काफी कम define की है stack depth initially, so that may not give you good fruits in the end. Okay, so keep the very descriptive and very, I mean, feel free to define your own stack depth. Okay, and keep it mostly the maximum. Okay, for example, if this stack is like 16 bits wide, and stack depth is defined as 100, then 200 bytes will be allocated for the stack storage. So it works like that. So feel free to give the stack depth here. Okay, then parameter. Now what is exactly this called as parameter here? So parameter is nothing but, it is a pointer that will be used as the parameter for the task being created. Okay, if we want to pass a pointer to a variable as an argument to the task function, we can use this argument. Okay, otherwise we can pass the null value. Okay, it is just like a parameter passing in function. Okay, the way we pass parameters. So if we, it depends on again our application. If we have certain parameters to be passed in a function, we have to mention while creating the task itself. So that is the parameter. Okay, it is a normal parameter. Okay, so अगर कुछ नहीं है तो we we write null. Okay, and priority. So we already know priority. If we create any task, okay, if we create any task, then its priority is very important to be set. Okay, the priority of any task is set by using, by user only, according to the complexity and requirement of the project. Okay, for example, like if we create our tasks and design them, or assign the priority 0, 1, 2, 3, 4. Okay, then the 0 means the lowest priority, and 3 means the highest priority. Okay, so it is as is that in free alphas. Okay, so that is priority. And then task handle. This task handle is, it is used to pass a handle to create a task. Okay, it is used to pass the handle to create a task. Okay, this argument keeps the handle of the function that we can use to change the function features. Okay, such as deletion of a task, changing its priority, etc., etc. Okay, so uh, हम जब को एक्चुअल सैंपल कोड देखेंगे ना, तो ये चीजें ज्यादा क्लियर होंगी तुमको. ओके, सो लेट्स चेक दैट आउट. ओके, बिफोर दैट लेट्स talk about few function. Okay, that we already saw basically. So it's like अच्छे से लिख दो. X task create. Okay, Okay, it is for task creation. Okay, then we have X task suspend. Of course, it is to suspend the task. सॉरी इधर भी V चाहिए, ठीक है, not an X, it's a V. Then it is definitely to resume the task. रिज्यूम करने के बाद टास्क आता है रेडी स्टेट में. देन डीले भी कर सकता है, ठीक है. vtask delay is a function. Okay, if you remember in assembly we were creating a delay. Okay, we were writing for loops and we were creating delay. So here we have a delaying task. Okay, delay generate करने के लिए ये task है, ठीक है. Then we have vtask delete also for of course deleting the task. So ये main functions है pre-R task के. Pre-R task. I'm mentioning this over and over again. Okay. So main function है delay ना. delay का जो function है ना vtask delay in FreeRTOS. So it's basically to generate a delay. Okay, but we pass certain things here in order to have the delay of our desire. Okay, and not the delay it offers by default. Okay, so if we want to change that, we have to pass that delay. We'll see how to do that in the code. Okay, so an important function. Now let me see if I that, can take that code on our whiteboard. No, wait. Okay, I know what is the problem. Anyways, let me present my screen only. So what can you see on my screen right now?
Sir, a code.
Okay, so uh, this code is where actually we are, how it defines, it declares, it creates the tasks, and it writes it as a function. Everything is there in this code. It starts here, okay, and the main. This is how we have created the task. Okay, X task. Okay, wait, it's not presented properly. Hmm. X task, X task create. Okay, task one. What was this? What was this? This is, it could be same or different. Okay, here in this argument we are writing the name of the function basically, which we are gonna write. I mean, it's kind of function declaration. Okay, and this is the description. Okay, you can write anything there. We have written task one only here. Okay, then this was the stack depth. Okay, then we have null. What is this null? This is a task handle. Okay, sorry, this is the task handle. What was the null thing? uh, Wait, null, what was this position? One, two, three, fourth argument. One, two, three, four. This is the parameter. So we don't have any parameter, so it's null. Then priority is one. Okay. Then the task handle. Okay. Task handle. This is they have mentioned my task handle, and my task handle mentioned to be null. Okay. So this is how you create the task. Now there are two tasks created, task one and task two. Okay, and they have initialized I and j to be 0, 0 first. Then what task one says is that if it is incrementing value of I, okay, and calling the delay wala function, okay, incrementing the value, calling the delay after that, then it's printing, okay, the value of I as it increments. Okay, and what task 2 states states is it is incrementing the value of j. Okay, then it is printing the value of j. Okay, then generating some delay. Okay, this is how the delay generating. They are passing some values here to customize the delay. Okay, so what it is saying is, if value of j has reached 8, then suspend. Okay, beta suspend my task one handle. Okay, task one handle is null. Okay, then the print task one is suspended. Okay, it's saying suspend task one once the j ka value reaches 8. Okay, and if j is 13, then again resume. Okay, again resume the task that we just suspended. Okay, when j is 8, suspend it. When j is 30, resume it. If j is 20, then delete it. Okay. So if you execute this code in FreeRTOS, you will see as we are printing the values. Okay. I'll try to show you. I will not show you. I'll try to, get. I'll try. I'll look for the screenshots if I have any. When I used to run these codes in RTOS. Okay, because right now in this laptop I don't have this particular thing provision to run this. So we'll see how can I do this. But basically this representation is roughly to show you how we manage the task. Okay, and now we are just checking the value of j, while actual execution it could be anything, right? Depending on anything. Okay, depending on the code flow, depending on the logic, depending on the conditions. Okay, it could be any condition. You can resume, you can suspend, you can delete the task. Okay, and so basically the task is nothing but the function. Okay, the part of the code. Okay, the only difference is the way we are running it. Okay, we are running it based on the priority, we are running it based on our needs. Okay, and this OS prioritizes that only. Okay, nothing but hardware specific priority is given to hardware, and that's the basic difference. It's a normal coding only, but uh, hardware has been given more priority. Here's the rough representation of how things would work. Okay, clear so far? Guys there?
Yes, sir.
Yes, sir.
Okay, so our talks. Okay, so do you guys have any doubts so far? Yes or no?
No, sir.
So I'll give you assignments, okay, today or tomorrow. Also tell me tomorrow, like मैंने 12 I mean 10 to 12 set किया है because that is the free slot available to me. Okay, so 10 to 12 I go attend. I'll try and cover maximum of this unit tomorrow and finish this up mostly. Like ज़्यादा कुछ नहीं है, मतलब है चीज़ें वैसे, लेकिन those are all like small concepts. Those will be covered. Okay, so you'll get few assignments on previous units and the current unit as well. The question bank will be given to you. Okay, so prepare accordingly. Just a second, I'm just checking something. Let's quickly just run through the content for the day, okay, and then wind up. We started with task management, okay, and I gave you the view of like how I mean the overall idea about the tasks running, okay. So we think that all available tasks appear, you end up executing at the same time, but no, that is not the case. It actually executes like this, okay, one task at a time, okay, for certain particular period and the rest for the other, okay. 1 2 3 1 2 3 1 2 3, like this it goes on happening, and we think that it's happening continuously, okay. Then scheduler, okay. The scheduler is nothing but a part of kernel, okay, which decides the execution, okay, depending on the execution policy, okay. Not the execution policy, the scheduler algorithm basically, or the priority, whatever we've set it. Okay. So preemptive, non-preemptive, 100 times we have seen. Fixed priority scheduling, dynamic priority scheduling. Fixed priority, definitely static, then dynamic, then depending on the deadline, and then rate monolithic is depending on the period, then different states of the tasks, okay. It could be the running or not running, okay. And how can it travel from one state to other, we've seen, okay. and what functions are there basically to get the task from different states sorted. Okay, so then there's a description of the states basically, then how to create, okay, how to create task, and this is nothing but the syntax. Okay, and these 5 arguments, this is a description of it, then functions, then we saw this code. Okay, here it is created. Go through it. If we have any doubts, reach out to me. Okay, so with this I will stop for the day. If you guys got anything to ask, reach out to me. I have a number. Okay, anytime, feel free. Okay, thank you so much. Have a nice day.